In this video, I am doing yet again another related rate problem. So take a moment and read the problem. In this problem, we have a geometric figure that we are working with here. So I always like to start by drawing the geometric figure. So we have a right circular cone, and it's a fuel tank that is in that shape. So a right circular cone, if you were to look at it from the side, would look like an isosceles triangle. And of course the top of it is circular, so I'll just kind of put in, there's the top right in there. And we know that the height of the cone is 50 and the radius is 30. So the height of the cone would be this distance here, which is 50. And the radius would be from here to here, which is 30. All right, so now let's look at the pertinent information for a related rate problem. Well, the next line says the tank can be filled at a rate of 112 cubic feet per second. Cubic feet per second, or cubic feet, is a measure of volume. So this is a measure of volume with respect to time. So we have the change in volume with respect to time being equal to 112. What we're looking for is how fast is the level of the gas in the tank rising after 861 cubic feet has been pumped in. So two things right there. We're looking for a change in the height, or the change in the height of the gas in the tank with respect to time. That's what we're looking for. But at that particular time, we know that the volume is equal to 861. So here are the three things that we're generally looking for in a related rate problem. We need one rate, which we have, dV dt. We need one fixed value, which we have, 861 is the volume. And we need to know what we're looking for. We're looking for the change in height with respect to time. Well, the formula that we use, which is given to us right here, has a little bit of an issue with it. Volume is equal to 1/3 pi r squared h. And that is that all of the information that we're given is in terms of volume and height. There's nothing about radius in the information that we're given. Now, granted, we're given the radius of the tank, but that doesn't really help us as far as the rate information goes. So what I'd really like to do is get rid of R, eliminate R from this. And we can do that by using similar triangles. So I'm going to draw a line right down here and a line across here. So let's call this little h here, and let's call this R. And so using the concept of similar triangles, which would basically say that R1 to H1 is equal to R1 to H1, I can say, well, R1 is 30, H1 is 50, and then my little triangle would simply be R and H. Well, solving this for R, we get R is 3/5 H. And now we can just substitute that into R in our equation. And so that will give us volume is equal to 1/3 pi times 3/5 H, don't forget to square it, times H, or volume is going to be equal to 9 pi over 75 H cubed. All right. The other thing that we're going to need to do is we need to find R. So we want to find H. Find H. Find H for a given value of V. So taking this equation here, we know that when the volume is 861. We were given that information right here. Volume is 861. We want to find the value of H that goes along with that. So let's just do that in red. So we have 861 is equal to 9 pi over 75 h cubed. Solving this for h, we're going to end up with h being equal to 13.17. 13.17. So we're going to need that information when we take our derivative implicitly. All right, so speaking of taking the derivative implicitly, let's do that. Here's our formula. Let's take the derivative. So the derivative of volume implicitly is 1 dv dt. And then all of this is a constant, so 3 times 9 pi would be 27 pi over 75 h squared dh dt. All right, so here is where we need to solve for dh dt. So solving this for dh dt, we would, I'm going to substitute in the value of dv dt. So the value of dv dt was 112. So we're going to have 112 times 75. And then that would be divided by 27 pi h squared. All that would go in the bottom. So this would go, we're basically dividing dv dt by all this stuff. So that's going to go in the bottom. That's going to go in the bottom. 75 is going to go up into the top over here. So the next thing to do is to substitute in what we know h to be. I probably should have done that in the last step, but I didn't, so I'll do it now. So 27 pi times 13.17, and that is being squared. Well, when you do all that in decimals, you're going to get 0.57. 0.57. So the height is changing at a rate of 0.57 units per second, or whatever the unit of time was. We could go back up and look at what the actual units were, but the number is 0.57. And that answers our question.